Hello class, welcome to week 11 of Programming Logic with Python. So in this class, in this video, I'm going to go over the homework assignments for this week. The first one's going to be Lab Activity 7.2, Defining a Class and Objects. So this week we are learning about classes and objects and methods and all that stuff, object-oriented programming. So Python itself is an object-oriented programming language. So this is kind of just, we've learned the basics and we're really going to start implementing our coding in the real world. So here they just want us to do a simple, create a class and then think of a class as like an object. So like it can be a person, it can be a thing, it can be like a computer, it can be a desk, it can be a person like myself, it can be a car, it could be anything. So a class is really just an object, and the stuff that we put inside of our class are what we call either methods or attributes. So I'll kind of go through at least this first example. There's going to be a separate video that explains classes and objects, or classes and methods a little bit more in depth, but in this video it's just going to kind of be about the homeworks. So for the first one, they just want us to define a tablet computer class. So to do that, we're just going to write the following. It's going to be class tablet computer. So we're always going to start our class with the keyword class. And then after that, whatever we want to name the class. And then after we give the name to the specific class, we're going to do a colon. Press enter, it's going to indent for you. And then after that, they want us to define the init function. So when we create a function inside of a class, it's not actually, in this case they said function, but it's not actually a function. It looks like a function, it might act like a function, but it's really called a method. So these methods contain attributes about at least this specific method, the init method, contains attributes that pertain to the class. So a tablet computer, some attributes that might pertain to a tablet are screen size, storage, and OS. So first they want us to create this function, so I'll create it. We still write it the same way, so def 2 underscores init, two more underscores, and then we do have to pass parameters in here. So the first parameter in any parameter, or this is like a parameter that's gonna be the same across any method that we create inside of our class. It's always going to be called self. Now self it's typically referred to as self, but you can really name it anything you want, but it has to be the first parameter that we include in our init function or init method. And it has to be included in any other method that we create. So if I were to create another method called def, what should I call this? I can call this like a Jeff. My name of the name of my method will be Jeff. And then I would pass parameters inside of it. I can do self. I can do like employee. You typically wouldn't do this, but I'm just explaining like how you could have multiple methods, but in each method you have to include the self. And self really just refers to meaning that this method pertains to the class of tablet computer. So self is used to reference the class tablet computer, but it also is used as a kind of like catch-all parameter when we do initialize certain instances of the class, which we'll do in I think the second homework activity. So I'm going to erase Jeff. We're still going to work with the first parameter of, or the first method of init. Another word for this method is the constructor. So if you come across something that says give the constructor of the class tablet computer, They really just mean that create a class method and name it init. You can't ever change this name. This is always the same, and we typically always include this in all of our classes because this is really going to define the attributes of this class. So we already know the attributes are screen size, storage, and OS. There could be more attributes, but in this case they just want us to use those. So when we define these, think of them as like creating variables and then assigning values, but we kind of want these variables to be specific to the tablet computer, and we know that the keyword or the parameter self refers to the class tablet computer. So the way to make these attributes pertain to the tablet computer, we have to do self period and then the name of the attribute, so screen size, and then we could equate it a value if we wanted to, but that kind of defeats the purpose of a class because a class is kind of like a blueprint for something, and we put stuff inside of the blueprint, and in this case our constructor or our init function or method is going to be used as like giving general placeholders for attributes that pertain to the tablet computer. And when we create other methods, or if we initialize or initiate certain, uh, I guess, instances of the class, so like if I were to do apple dot, well, actually would it be apple dot? Well, we'll get to that. Yeah, let's not get too ahead. So like if I were to, yeah, actually I'll mention this. So if I were to do iPad dot or equals tablet computer, tablet computer, and we're calling it the same way we would call a regular function, like outside of a class. So it's like a new variable, iPad, but this is really the instance of the class. So an instance of the class just means that like I created a blueprint inside of my class for a human being. I gave attributes of a human being like their arms, their legs, their eyes, their lips, all of that stuff, but I never equated a specific value to any of those things. And when I create an instance of a class, I'm like specifying a specific human being, but in this case we're referring to tablets, and I'm specifying a specific tablet being the iPad. So the iPad, I'm equating it to the function or the class of tablet computer, and the way we do it is with this syntax. So you name the name of the class, and then you put the two open parentheses around it or outside of it, and then you would typically pass arguments here. So when I pass an argument, this is really referring to all of the attributes that I created inside of the init function or init method. So right now I only have one, it's screen size. So I would have to pass a argument that fits screen size. So in this case, I can do like a number, so I can do like what are tablets, like 11 inch, so I can do like the number 11. If I were to have, well, let me finish this specific attribute. So I did self.screenSize, and I'm equating it because I don't want to give it a specific value because I'm going to give the value later on. I can just give it the value of screen size, and that's it. So if I'm going to do that, then up here I also have to include the parameter of screen size as well. I don't have to do self.screenSize up here, just screen size. And then if I were to include other ones like they want us to do for this assignment, I have to do self. And remember, the whole reason of writing self dot whatever is to make sure that all of these so-called variables or attributes pertain to the class of tablet computer. Or else if I didn't do the self dot whatever, then they would be local variables. So like they wouldn't be able to be used outside of this specific function or this specific method. So if I were to create an instance of this class, the instance being iPad, and then try to pass arguments into it, then it wouldn't know about this specific variable or attribute because it's a local variable because I didn't include the self dot period or self period whatever. So in this case, I'm going to do self period storage equals, and I'm just going to do storage. And then if I do that, I also have to include it up here. And then I'm going to do one last one, self period OS equals OS, and then I can put OS up here as well. So now when I run this, or when I call it, I can do something like 11, or actually I don't even have to write this. They already did it for us down here. So they put UPad. I don't know what a UPad is, but I'm assuming it's just like they meant iPad. And then they did equal the name of the class, which is tablet computer. And then inside of here, they do 12.9 for the screen size. They do 1 terabyte for the storage, and they did this like in a string. And then for the OS, they did UPad or OS 13.5.1, and they put all of that in a string as well. Notice that they only pass 3 arguments, but we have 4 parameters up here. The reason that is because UPad actually takes the place of self. It actually becomes the first uh, argument that's passed, even though it's not included here. So self refers to the class of tablet computer, and then when we create an instance of this class, UPad takes the place of the first parameter. It's kind of weird, but that's why we have to include self. So when it passes all of these attributes, it's really upad.screenSize equals screen size, which is 12.9, and then upad.storage equals storage, 1 terabyte. So like upad kind of takes the place of self in all of these kind of placeholders up here. And then when I create another instance of the class, root pro x now takes the place of all the self up here. So it's just, this is kind of like the blueprint, and then whenever we create an instance of a class, we're creating a specific thing. So like different types of tablets, that's what this is kind of referring to. But the attributes of any tablet stay the same. They all have a screen, they all have storage space, and they all have an operating system. So that's kind of like, this is all one object, a class is an object, and all of these are instances, these are all specific types of objects. So I believe that's kind of all they wanted us to do for this. After define the class, yeah, they want us to run the code, so Python 3 main.py. They want me to put I think I forgot a colon right there. Yep, I think that's what they wanted. Yeah, 4 out of 4 checks passed. Okay, so they just kind of put a bunch of different strings right here, like print statements, which made me think a second because it's kind of messy the way they did it. I wish they kind of like generated new lines so that it just looks neater. But this code was already given to you. Our code was really just creating the class, creating one method, which is the constructor method, the init method, creating 3 attributes inside of it, and then within our method we have to also put those attributes as parameters in it, but we cannot forget about the self parameter. And then these 2 instances of the class were already created for us as well. So yeah, it's pretty simple. We just created a class. So that's it for 7.2. For 7.3, which is the second assignment, just go to start. So this one's a little bit more complicated, but it's not too complicated, but it's just like a little bit past what we just created. So we created one method. Now here we're going to create a couple different methods. We're still going to create only one class, but the class is going to have different methods aside from just the constructor. So for this, they want us to, you're part of a race team building a program to help children learn math in a fun way. Currently, you're building a module on shapes, more specifically calculating the circumference and area of circles. So the formula for calculating the circumference of a circle is 2 times pi times r for radius. The formula for calculating the area of a circle is pi times radius times radius. So they want us to write a Python class named wheel, so I could kind of just like start doing that without even getting to the steps. So Python class wheel, constructed by a radius and two methods, which will calculate the perimeter and the surface area of a wheel. The script should ask for the user's input for the radius. They kind of already do all that for you. Create a wheel object and print out its surface area and perimeter. It should ask for the user's input again. It should use the math modules and set the pi constant as your value for pi. Okay, so they kind of do step by step. That was kind of just like the general purpose of our class and the data we're going to put inside of it. But for the steps, step 1, define a wheel class and the wheel constructor method. So when you see wheel constructor method, they really just mean define a function or method, the init function. So we created our class wheel. Don't forget the colon, and then it will indent for you. And then our constructor method will be so def 2 underscores in it, 2 more underscores, and then it changes the color of the word. And then we have to pass, we know in any method we create inside of any of our classes, we have to include self as the very first parameter. So I'm just going to write that before I include anything else. There probably will be something else here, but I'm not going to include it yet. We're just going to get to the attributes first. So we just looking up here from all these different calculations that these methods are going to do, we know we have to include pi, but pi can be imported from the math method, so we don't have to really worry about that. 2 is just kind of like the integer 2, so we could just include that whenever we need it. And then radius is something that we kind of have to define as a global variable. And the way to do that is first including self in our constructor method, but also defining radius as a attribute of wheel. So to do that, we do self dot radius, and then we're going to equate this to radius because we don't know what the value for radius is. We're just kind of putting a placeholder for radius for now. So if we're going to do that, we have to include radius up here as well. And that's pretty much it for our constructor. So we could kind of move on to the second method that we're going to create. So the second method would be create the wheel underscore area calculation method. So this method's going to take in a calculation. So I'm going to do def and then wheel underscore area. And then inside of it, I already know I have to include self. Self is included in all of the methods or functions that we create inside of a class. So it's going to indent for you. So here they want us, they want us to return the surface area of the wheel. So to get the surface area of a wheel, you would do pi times radius squared, and they want us to return this, so it's going to be return, and then we're going to use the math method that we imported up here. So math.pi. We're going to do this anytime we want the value of pi for any calculation that we're going to do throughout this program. And then we're going to do multiply by radius, and radius, because it was already defined as a global variable up here, I can just do self, I have to include self, period radius, that way it knows that I'm referring to this global variable of radius up here. And then to take a number to the power of something, we already learned this before, it's just the double multiply symbol, and then whatever power you want to take it to. In this case, we just want to square that radius, so we just do the double multiplication and then 2. And then that's it for this wheel area method. So we can move on to the next method we're going to create. So def, they want us to create a wheel perimeter method, or calculation method. So same thing, it's going to be wheel underscore perimeter, and then we're going to do the self right here, and then colon. So it's going to indent for you. They want this method to return the perimeter of the wheel. So to find the perimeter of the wheel, it is 2 times pi times r. So I can do return 2 times, remember math.pi, times radius. So to get radius, we do self.radius. Okay, so that's the third method we created. So we're going to create one more method. So the last method is going to be swap radius. So just write that out. And we're going to include the self parameter as well, colon. So which sets new radius as the radius of the wheel when requested from user input. Okay, so we have our original radius of self.radius, and they want us to give self.radius a new value. Instead of radius, which is the original value up here, they want a new value, and this new value is going to be called new radius. So new underscore radius. And remember, this is not an actual value. This is kind of like a parameter. It's like a placeholder. So when we end up calling this specific function or this specific method that exists in the class wheel, it's actually going to take another value, which is actually down here. So if I do python 3.main.py, radius of the wheel, let's do 4. Okay, gave me a error. Let's see where we made the mistake. Def init, self radius, radius. Return math.py dot self radius squared. Turn to self radius underscore new radius. When you run the script will ask the user for input, calculate the surface area and perimeter, print out that. Okay, well, let's see what the task gives us. I don't see anything wrong with this. 4 to 4 checks. Script accepts users' input for radius values. Okay, so it's not liking this, so let's see. Input 2.2. Okay, so they want us to do, so let's do python 3 main.py, and let's try 7. Line 23. Wheel.swap radius, takes 1 positional argument, but 2 are given. Oh, you know what? I didn't give the, so because I put a parameter for when I replace the value of self radius to new radius, I have to include new radius as one of the parameters up here for the method of swap radius. I forgot about that. So that's, it was trying to take when it was trying to pass arguments into it, down here, so wheel.swap radius, and then it's passing 1 argument of radius, which has the value of whatever this calculation is, which is a user input. It's putting wheel as wheel.swap radius. Yeah, it's putting wheel as the first argument, and it's replacing self. And then it was trying to put radius as the second argument, but there was no second parameter for it to take its place. So that's why we had to include new radius. We've done this in previous, at least in the last activity, and I did it up here as well. I completely forgot about it here. So python 3.main.py. So radius of wheel, we do 7. Okay, so now it's taking the radius of wheel, it's giving me the surface area of the wheel, the perimeter of the wheel, and then here it's saying, do you have more wheels? I'm going to say no, because if I did, I think it's just going to run the program again. So we could do 7 again, and then we could do yes. And yeah, it's just gonna ask you for another radius for like another wheel. Like if your car has 4 wheels, we would just do that. So if I check this off, it should give me the passes. Yeah, okay. So really here we created a class called wheel. We created 4 different, well, yeah, 4 total methods, or like I said, methods are functions that exist inside of a class. And the difference between a regular function and a function that exists inside the class is the inclusion of this self keyword. This self keyword always will be the first parameter passed in any method that you create inside of a class. It just helps Python know that this specific method is referring to the class of wheel. That's all it's doing. And whenever you initialize um, a uh, initialize a um, kind of like a instance of the class, it would take the place of self, and then any other parameters would be would you would have to pass arguments when you initialize that um, instance of the class. So here they initialized the instance of wheel, and then they did the wheel class right here. And the way we know that these are different things, this is the instance and this is the actual class, is that the class has an uppercase W and the instance has a lowercase w, and we're passing only one argument. And that one argument is actually taking the place of radius right here, and the instance of wheel is taking the place of self right here. So that's kind of what that is. And then when we do more wheels is kind of just a Boolean argument right here, which is why we assigned it a Boolean true value. And then they just did a while loop right here. So while more wheels is true, so this is going to run. And then they did a calculation for radius, so float user input radius of wheel, and that's what we entered in at the very beginning of our program. It asked us for the radius of the wheel. We entered in a integer value or a float. It could have been a float, so I could have put like 6.4 and would have accepted it. And then after that, it did a wheel dot. So wheel is the instance of the class. So if I wanted to assign like a value to this instance of the class, because remember when we created this class and um, we created the attribute of radius, we didn't actually give it a real value, we gave it a parameter value. So down here when we created the instance of the class, we gave it an actual value, which was the user input. And then here they're just printing it out. They're printing out the methods. So the first method is the wheel parameter. So that's this third method that I put right here. And then the second one is wheel underscore area, which is the second method. The wheel or the fourth method is used right here when we are assigning a new value to the radius of the instance wheel. And then the first method of our class is kind of just always used because it's really just like think of it as I guess blueprint. Like the whole class is a blueprint, but this constructor method is kind of like the empty values. So like if you have an attribute, like I said, for a person, right now we're talking about a wheel. In the previous example, we were talking about what was it? I think it was a car. No, it was a tablet. Yeah, so if we were talking about a tablet, if we're talking about a human, all of these, I'm just gonna wait for this to load. All of these attributes are kind of like characteristics of whatever the class is. In this case, it's tablet. In the other case, it was wheel. In future examples, it might be like a human. It might be an actual like a desk, like an actual thing. So object-oriented programming just allows us to create an object, assign it attributes, and then when we create other methods aside from the main constructor method, those methods kind of tell us what that object either does or kind of like uh, other not characteristics, but yeah, what that object can do. So it could, if I were referring to a human, if this class was a human, and my constructor of init kind of gave me characteristics of the human, so like the name of the human, the age of the human, and the job, like the employment job of the human, then my other methods can be like, what does the human do? Does the human run? Does the human walk? So those methods can be related to that. And then when I create instances of my class, I can do like names of actual humans. So I could put my name. So instead of UPad, I can put so it could be me. It could be Professor Gonzalez, and then instead of pretend this isn't screen size, pretend this is like um, my age. So if it's my age, it can be like whatever it is. Then if I were to put my name, I'd put my name as Professor Gonzalez. Well, actually, then here I would put teacher one. Actually, no. Let's not do Professor Gonzalez there. Let's do Python Professor. Yeah, that's better. So Python Professor, and then my name, and then what was it? My employment. So Professor, and then that's kind of what we would do. So like, it doesn't restrict us. So like this constructor gives us placeholders to enter in like a human's age, a human's name, a human's employment status. And then when we create instances of the class, it's like when we're creating specific people. So you might have another professor, you might have like a networking professor, and then their age might be like a little bit older, they might be 40, their name will be like Jeff, and then obviously they would also be a professor. So do you kind of see how it just creating classes, another word for a class is an object, um, gives you more flexibility when you're creating a specific thing, like a tablet, a human, whatever. You give it its attributes, you generalize those attributes by assigning parameters, and then when you create an instance of that class, you create specific things, like specific um, yeah, specific people, specific tablets, so like an iPad, an Android tablet, an iPhone, stuff like that. So that's kind of the basics, I guess, of classes and objects. It's going to get a little bit more complicated as we go on because right now we just covered the first 3 lessons of this. We're going to get into inheritance. We kind of covered attributes and we kind of covered methods. So lesson 7.4 and lesson 7.5 kind of like the same of what I just explained. But I guess that's it for now. There will be another video where I kind of explain it a little bit better. But for now, I just kind of wanted to show you what the code should look like and why it should look like that. And that's it. So I will see you guys in the next video. There will still be another video for this week. And just do your homeworks, do your reading. The reading will help. And I also suggest going through the PowerPoint. I did kind of explain all of this in the PowerPoint as well, so let me pull up the PowerPoint. So right here. So it's not too many slides. I think it's only like 14 slides. So I have classes and objects. I have creating a class. So creating class is just the keyword class and then whatever the class's name is. Creating an object. An object it's really like the instance. So when I was referring to instance, an object, they kind of refer an object as that, but I refer an object as the class itself because that's really what it is. An instance is equated to the class. And then the instance takes the attributes from the class as itself. So like P1 in this case is being equated to the class of my class, but P1 is also taking all the attributes from the class myClass. So in other words, P1 can be like the name of a person, and then myClass can be like it could be like human. So and then we have the init function, which is really the constructor of a class, and then we have creating a class, so we have class person. Okay, so person. And then we have our constructor right here. The constructor has self. Self is always there. You can never forget self, or else your code is just not going to work. All of these attributes will be local instead of global, and then that can be a problem when you try to create an instance of the class. So P1, and then you equate it person, and then you try to pass all of these arguments. If you don't have self in here, and then you don't include self here, all of these variables or attributes won't be available to be like have arguments passed through them. So like John and 36, all of this will fail if you don't have self. And then they're just printing out P1 object methods. So they're just saying, aside from your regular constructor, you can create other methods. And then self parameter, they tell you about the self parameter, example of self parameter, and yeah, that's pretty much it. So, and then they do tell you like other ways to modify your instances of a class. So like you can delete age, you can delete an object, or you can delete an instance completely. If you were to create an empty class, you can just pass it. That way it doesn't return an error when you run the code. And that's pretty much it. So yeah, go over the PowerPoint, do your reading. This was just kind of to try to help you guys with the homework. And there's going to be another video about like more step-by-step of classes and objects and methods. So yeah, that's it for now.